In number 10, we're solving these trigonometric equations by factoring. Different types of factoring may need to be used here. So in part A, we have secant squared theta minus 1 equals 0. So if we're going to do this by factoring, this is a difference of squares. So I can write this as secant theta plus 1 times secant theta minus 1 equals 0. So the zero product property tells us that secant theta plus 1 can be equal to 0, or secant theta minus 1 could be equal to 0. So if we solve both of those, this is secant of theta is negative 1. Here secant of theta is positive 1, which means 1 over cosine theta is equal to negative 1. In this case, 1 over cosine of theta equals positive 1. So if we're solving this, if we cross multiply, cosine theta times negative 1 is equal to 1. So cosine theta equals negative 1, and I can find where that happens. So the only location where cosine is equal to negative 1 is at 180 degrees. Solving the second equation here, 1 over cosine theta equals 1 would mean that cosine of theta is equal to positive 1, and that only happens here at 0 degrees. On part B, we have two terms that have a common factor of sine theta. So I'm going to take out the common factor. Then here we're left with another difference of squares, so sine theta and then cosine theta plus 1, cosine theta minus 1 equals 0. And now all three of these could be equal to 0. So sine of theta equals 0 would give me a solution at either 0 or 180. Here cosine theta plus 1 could be equal to 0, which means cosine theta is negative 1. That gives us a solution of 180. Which we've already listed here. And then lastly, we have cosine theta minus 1 equals 0 from this factor. So if cosine theta equals positive 1, we're here at 0, which again, we already got that solution from here. So there's only two solutions, either 0 or 180. All right, let's look at part C. Here we have a trinomial. So when you're factoring a trinomial, you can factor this the same way that you would factor a trinomial that has a variable x. So you could do it this way. A times c is negative 2 and b is 1. So we would want 2 times negative 1. If we're going to factor by grouping, this would be 2 cosine squared theta plus, and then we're splitting the middle term into these two. So 2 cosine theta minus 1 cosine theta, and then the last term stays the same. And then grouping that, we get 2 cosine of theta times cosine theta plus 1, and then minus 1 times cosine theta plus 1. So the two factors we get here are 2 cosine theta minus 1, and then cosine theta plus 1 equals 0. So if we set each of these factors equal to 0, 2 cosine theta minus 1 equals 0. If we solve this, we can move the 1 over and divide by 2. So cosine of theta is 1/2 at both 60 degrees and 300 degrees. And then solving the second equation, if cosine of theta plus 1 equals 0, that means cosine of theta is negative 1, and cosine of theta is negative 1 at 180 degrees. So we have three solutions, 60, 180, and 300 degrees. All right, lastly here we have part D. Here we have two terms with a common factor of sine theta. So we can take the sine theta out. We're left with 4 sine theta, sine squared theta, minus 1 equals 1. And actually, I think this should be, we should subtract the 1 first here. Actually, let's just make that a 0. So if this is a 0, then here we have a difference of squares, so sine theta times 2 sine theta plus 1 times 2 sine theta minus 1 equals 0. So any of these three factors could be equal to 0. So if we set sine theta equal to 0, sine is equal to 0 when we're at 0 or 180. If we set 2 sine theta plus 1 equal to 0, and we move the 1 over, this would be sine of theta equals negative 1/2, which occurs at 330 and 210. And then lastly, 2 sine theta minus 1 equals 0 would give us 2 sine theta equals 1. Sine of theta is equal to 1/2. And that would occur both at 30 degrees and 150 degrees. So here we have 6 different solutions. 0, 180, 330, 210, 30, and 150 would be solutions to that equation.